Welcome back, grade 12s, now for the dreaded question 4. Right, there's quite a lot to read. So, bottom line is we have a text file called waste.txt. And we have a look at the text file, we can see it over there, there's semicolons and hashtags. We don't have to worry about that because right at the bottom of this page it says code has been written to read the items from each line of the text file into 2 global parallel arrays and AR data and AR weights, and after that code has been executed you'll have these 2 arrays which will be parallel to each other. This is just 3 items from the array corresponding to the text file. That gets read into AR data, that gets read into AR weights, and if you study the code here, it's always good to know what you've got. So you go and look at the code, you look what's going to happen, and it's explained, and then when you run the program you'll see the results because it will be displayed in the rich edit. So we'll run the program quickly. Silent pause while we wait, and there it is, the text file in a nutshell being separated into 2 different arrays. And as you can see there's a lot of duplicates. There's cardboard recycled, trash landfill. We'll refer to that later, and those are the weights for each type of waste material that has been recorded. Now we're going to go to our user interface. We have a combo box, we have a panel, and we have weights of waste products in kilograms. The question goes on, well, describes our array of types that we have, a constant array. In other words, that is a constant array. Let's see it. There it says COST, which means nothing in this array can be altered, and there are 15 boxes, and each with a different description in each. Looks like this, 1, 2, 3, all the way to 15. Oh, I forgot to mention, when they read from the text file into these 2 arrays here, there was a counter called rcount. We must take note of that. It's a global variable that's going to be counting the number of rows from the text file, and then goes to maximum of 100, but rcount will be less than 100 in this case. So happens. So let's move on. We know that those 2 global arrays are parallel, AR data and AR weights. We know what they each contain. And rcount holds the number of items for the 2 parallel arrays. They tell you about the code, and on activate event there's a repetition of description there, and it displays in the rich edit we've just seen. They say modular design must be applied even though no marks were actually allocated to it, but we need to be warned about that when we see that. Maybe there was a mistake, but in your final paper it won't be a mistake. You must write code in the on-change event of the combo box name CMB report. So on-change, and they have given it to you here. And if you can't find the on-change event, if it's not there, then you go to your combo box, you click on it, go to events, and then you click find on-change, and you double click in the white area next to it. So if it was on click or whatever, then you would double click in there, but it's on change, it has already been implemented and might not be in your final exam, so take note of that. So they say combo box option, total weight of all wastes. Now you must know that you have an item index property of your combo box, and you need to go and see what the items are in the combo box, even though it's self-explanatory that the first item is total of all waste, so that's item index number 0, and that'll be item index number 1, and then item index number 2 for the percentage, and the last one is item index number 3. So we established that as a fact, as facts. So of course, you know, case CMB report dot item index. I just reminded myself that in my first question I forgot to add the dot item index for the radio group box of 0 and 1 and 2 and 3. Of course there's going to be a lot more than that, that's just my skeleton. We might have to put begin and end in there. Let's see what else we have to do now. Okay, total of all weight of waste materials collected. So now we know that the weights of all waste material is collected and stored in ARR weights from 1 to our count. So if we're going to go through every single box of the array and add up things, we use a for loop. 4k equals 1 to our count. Right, and then we're going to get the sum of all the weights. Okay, fine, I might do it inside there, but let's read on. Combo box, get the total weight of all recycled waste. Right, all recycled waste. So we're going to go through the same weight array, ARR weights, but we're going to go look in the corresponding array of AR data and see if it says recycle and then add it up. Okay, so that's another big thing. So we know more or less what we're going to do there. Then in the third one, percentage of recycled waste. So what we're going to do is get the recycled weight that we already got in question 4.2 and find out what the percentage is, because it is actually recycled weight divided by the total weight, which was in 4.1. we got the total weight in 4.1. Oh, we haven't got it yet, but I mean we're just going through to see what we can do about modular programming. Multiplied by 100 and rounded to a whole number. It's a very important point, the rounding story. So I'm just highlighting. So the recycled waste, which was 4.2, divided by the total weight, which we got in 4.1, which we will get in 4.1, multiplied by 100, and then we round to a whole number, and that will be our percentage waste. And that's going to be 4.3. Then 4.4, total weight of each waste product. Okay, so this means we're going to add up. We're going to add up all the paper, add up all the cardboard, add up all the trash, and use AR types to do that. AR types contains paper, cardboard, trash, timber, etc., etc. 15 different types. And we can add up everything that's paper and everything that's cardboard. Okay, that doesn't work with our total weight. That's a little bit more complex. So I'm going to go and I'm thinking now, because total is going to be used twice, we're going to use the total weight for the recycled waste. We've got to display it, and then the percentage of recycled waste is going to use total weight as well. I'm going to write a function called get total. So before I even carry on over here, I'm going to write a little method here, and this is where my modular programming can come in. Function get total colon integer, and highlight it. Control Shift C. I don't have to have any parameters coming into my function, and the reason is because why? My arrays that I'm dealing with are all global, and I'm going to go through all of ARR weights and calculate a total. For getting the total weight, we don't have to worry about what kind, if it's recycled or landfill or whatever. We just have to worry about AR, the weights. So here's my little function I've written here. I'm going to use a for loop going from the first box of the array to r count. So for k equals 1 to r count, do, and then I'm going to have a okay, we're going to have an I total because it's actually an integer. You have to have our little variable that we can use to calculate with there. Set R total to 0, and then in the for loop, and I don't have to do anything else, sum up all the weights, AR weights, square brackets k. Is it called AR weights? Yes, it is. And there's my total, but this function is not going to have any result unless we say result equals R total. And there it's written. So R total is our total weight, and we know that get total is going to return the value. So in my comma box option for 0, I'm just going to say we're going to display in the panel. Does it say, yeah, display in the panel, P&L output. Wait, 4.1, eh? Display in the panel name P&L output. I will say P&L output dot caption equals int to string get total. So there I'm using modular programming. Unfortunately, there weren't any marks allocated for modular programming in this instance, but be warned that in your final exam there will be, if they have that statement there in the paper. Use modular design. Right, now the next one is the recycled weight only. Look, I can make another function for recycle, but I've made one function already, so it doesn't matter. I don't have to make another one. But anyway, we'll do it just for fun. Get recycled integer. And we will use the same variables. Why not? Copy and paste. Makes your life easier. I know I'm going to go from one box right through to the end, but there's an if here, an if statement involved, where we're going to say if AR data, in other words the array, because we want the recycled only, which means we're going to go and check through the array to see if it contains the word recycled. And now recycled is with the capital R. But if we just go and change everything to uppercase, then we're good. Yeah, well, we use uppercase. If pos of the capital letter recycled exists in AR data, box number K, but if we're going to do that, if it's not equal to naught, if the position is not equal to naught, in other words it does exist, we must actually uppercase every item in AR data so that we can be sure to get a match. Can you see this is a function I'm writing? We could have just put this into our case structure for number 1, but we're writing a function, get recycled. So, are we happy with this? It says capital letter recycled, then we uppercase everything in arrow data K. What has arrow data K got? Well, these are the strings in arrow data K. As you can see there they are. if it contains the word recycled, we want to add up the weights, ARR weights. So we're dealing with two arrays here. They are parallel, and using them together, and our count is the number of boxes that are filled for both of them. Because they're parallel, we can do this. Right, so our result will be whatever that total is, and it's an integer, and it's a function called getRecycled. So we're going to go call the function now. We say PNL output dot caption equals integer string get recycled. So there we've successfully used modular design, and we're going to use get total and get recycled in the next one, because that is asking us the percentage of recycled waste, which is the total weight recycled divided by total and multiplied by 100 and rounded. So I can do it in one line. Let's see if I can do it. Output dot caption equals float to, oh, actually it's into string because I'm rounded, aren't we? We're going to round it. Int to string get recycled divided by get total times by 100. Yeah, fine, but we have to round that, don't we? Now let's see if that is correct. We'll see now. So we're using our superduper functions here. So let's see. 112410 recycled waste, and the percentage of recycled waste is 46, spot on. Not so difficult, eh? Right, but number 3, that's a bit nasty. Always is. There's always one that's not so good. 4.4 option 3 over here for case item index number 3. Remember this one, I'm going to put begin and end here. Now you must remember that your case has an end. Case itself has an end with no begin, but you must have begin and end if you're going to do more than one thing for an option. In this case we're doing many things for 4.4. So we have duplication in our AR data, as you can see, cardboard recycled, whatever. There'll be another cardboard recycled over here, maybe, you know, down the line we'll have another cardboard recycled with some random number. Okay, oh wait, not that number, and not that one either. Okay, and we want to basically add up all the cardboard, all the paper, all the trash, all the timber. So wherever there's cardboard, we want to add up. We don't care if it's recycled or not, or landfill. We just want to add up the weights. Let's have a look and see if I'm correct there. Unique types of waste that are being disposed. Uses information to calculate the total weight for each unique waste type. Yeah, that's right. We're not worrying about whether it's recycled or not. We're just worried about the waste type itself. And write the results to a text file. We're not going to display the results, we're going to write them to a text file. So if you did display in the rich edit, then you did unnecessary work. We just write into the text file. That's all we're doing. Well, there's a couple of ways we can write to the text file each time we find a match, or we can put all our totals in variables. Now there are 15 types. So if you're going to have totaling variables for 15, that would be not good programming technique at all. You can't have 15 different variables. You can have an array of 15. Yeah, that's better. Use an array of 15 for your totals. So AR totals, 1 to 15 for each of these types here, because you have to write the type and then the total next to it. But okay, fine, we've talked about the output. What about how to do it? Well, you'll go through AR types and you'll go through AR data, because we've got to go and see a matching type in a data. Shall we first go through AR types and then through data, or we can go through the data and then through the types? In other words, we can go through each box of AR. We can take paper and then go and look for all the papers. Then we take cardboard and look for all the cardboards. Yeah, well, let's do it that way. So we are going to go through every single box of AR types, and we're going to go through every single box of AR data. You're not stopping any loop. We'll use a loop for both of them, and we'll definitely be going through each one of them. So therefore, for loops are the order of the day. We'll go through all boxes of AR types. So let's use a for loop from 1 to 15. So I know I'm going to use 2 loops. So I'm going to make 2 loop counters, K and L. My first one for K equals 1 to 15. We'll go through the array called AR types. Oh, heaven's sakes. Right, so going through AR types. Right, let's just say we'll make a variable just to make it easy to understand. S type string. We take the first type. S type, always think of the first one. Okay, so we got the first type from the box. We're going to take that paper and go through the array of AR data and see if it exists in each box of AR data. So then we need to go through AR data with that first type. So I'm going to say for L equals 1 to, how many times? Well, AR data, remember, has R count as the number of boxes that are filled. Do begin and end. Always have begin and end. Can you see how it's nicely nested there? Now we're going to ask the question, if, well, fine, I will go and do this S string or S line. Let's say we're going to say S line equals AR data square brackets K, just so that you can see the for loop, the first for loop, the outside for loop is going to go through each box of AR types. The inside for loop is going to go, that's L, not 1. L equals 1 to R count. And so this must be an L here. S line, we're going to go and check in the first box of AR data and see if pos of S type in S line, if it's not equal to 0. What are we going to do if it's not equal to 0? We want to write to the text file. Actually, no, we want to get a running total. And we want to store it into, actually, I would rather put it into an array. And the array must match AR types. So we will have an array counter, ARR total types. Okay, so there we have another array, and that's going to be parallel to AR types. I would think that this is the easiest way to do it. And we have to initialize each one of these boxes with zeros before we continue, because we're going to have running totals in each box. So you have to initialize them. And we've got to get zeros in each one, because we want to have a total for paper, total for cardboard. And when we find paper, we're going to go and add 2543 to that one. Oops. can you see these two arrays here are parallel. Okay, I'm gonna shade them green so you get the idea. We're going to make an array which will be parallel to arrow types. So we'll make another array called arrow total types, or arrow totals. I suppose it'll be easier. Arrow totals, so that we can store all the totals inside an array which will be parallel to arrow types. Where are we going to declare this array? Well, we declare it in our button click, the CMB record change events. So I'm going to call it arrow totals colon array 1, 2. Well, if it's going to be parallel to arrow types, then it must be 15 boxes of integer. There we go. And before we actually go and do anything, we need to put zeros into each box. I'm going to use another variable, for loop variable, for m equals 1 to 15. I've got to quickly do this, I've got to put zeros in. Because if you don't initialize local variable counters, they're totaling variables. I mean, they're all a whole lot of totaling variables in here, so we've got to put zeros in them. Sorry, wrong one. Before we even start adding up all the paper and the cardboard and the trash and so on. Okay, so we've got to fill it up with naught first, and then over here we can go and add up arrow totals, square brackets, which one? It'll be K. See, this is the trick here. It's going to be equal to the previous arrow totals box number K plus AR weights box number L. Now, where did I get the K and the L from? You must remember that K is going from 1 to 15. Okay, don't worry about this now. That M was just used to go and put 15 in there. I could have used K, it doesn't matter. Wouldn't have made any difference if I used K here as well, because we're starting over from 1 in this statement here. So for K equals 1 to 15, we're going through arrow type. So we box number 1 for the type. Therefore, box number 1 for the totals is what's going to be added, having the weight added to it. But arrow weights, we're using L because it's going from 1 to R count. So this is filling up our array with our arrays of totals with the weights, adding up all the weights to arrow totals. Go through this again. We had arrow totals going from 1 to 15, where we filled that up with naught, all noughts in all of those boxes of arrow totals, 15 boxes with noughts inside them. Then we're going to go through each box of arrow types, take that one paper and go and see if it exists in box number 1 of arrow data. So arrow types we're using, going through from 1 to 15 using a K, and then once we've got our type, and then we go and check, we go through every single box of ARR data, and that's going from 1 to R count. That's going through every single box. L equals 1 to R count. We get the string from arrow data. We see if the type is inside the string called S line using pos. It's a quick way to find out. Always remember this trick. This pos works brilliantly. Then and if it is, which means it will not be equal to naught, then we can go and add our weights. Just one little thing, S type an S line, why don't we just do this uppercase? So we're dealing with capitals all round. There we go, we're dealing with capitals, so we know we're not going to have any issues, even though it doesn't make any, it still works. We don't have to do uppercase, it's just an added feature. We don't have to do uppercase actually because of the fact that paper and cardboard, there are matches. It is spelled the same with a capital C and a capital T and a capital, a capital P and a capital R. They are spelled correctly with the capital letters, but just to be safe, we're using that. Then we say if pars of S type and S line is not equal to naught, then we are summing up our array of totals, which has got to match the array of types. Therefore we use box number K, that one. And then we use box number L to refer to the actual weight inside the parallel array for AR weights. And that's that. Done. That option is done, but it's actually not finished. The option for number 4 is not finished. We have to go and write to text file. So it might be a good idea for you to do this end of case. This end here is our end of our case, and this end here is the end of option number 3 of case, just so you can get our facts right. And then make sure that you have your matching begins and ends like such, and this one doesn't need begin and end because we're only doing one thing, filling it up with noughts. Right. Okay, next thing we have to do is write to text file. Well, we've got AR totals. After this block of code, we have AR totals with numbers in, and it'll look like, something, like such and such and so. Just to give some ideas, we'll have it all filled with numbers. Okay, we'll have it all filled with numbers, paper and cardboard and that number, trash and that number. So we have to work with AR types and AR totals, and we're going to go and display that in the in a text file. We're going to write it to a text file, and they're telling you to, let's go and look at the instruction quickly. Calculate, okay, in each time, write the results text file name or report.txt. Now when you write to a text file, we must either append or rewrite. So that it must be created. It says it must be created using Delphi code fine. So we say assign file. We need a text file variable, and the text file name is report.txt in single inverted commas, and then we say rewrite tf. Now tf is my text file variable name. I'm going to declare it here in the local variables. By the way, you must try not to use global variables. Use as few local variables as possible. And then once we've got the rewrite, now we're going to use a loop. And the loop is going to go from 1 to 15 for AR types and AR totals. Remember, there's 15 of them. AR types and AR totals, they're parallel. So we say for, we can use K again, equals 1 to 15, do, and I'm only going to do one thing, so I'll say write ln tf, comma, and the format of writing must be paper equals, cardboard equals, and so on. So we're going to say ARR types, square brackets K, plus an equal sign, plus, now AR weights is an integer, so int to string not error weights, AR totals is AR totals square brackets K. And there it is, only doing one thing. Make sure you use the right number of brackets. And then you've got to say close file after the loop, close file TF. And there it is. That wasn't so difficult, eh? So that's the end of option number 3. Quite a lot for number 3 option. And we use modular programming for those other options. We'll run the program quickly, so make sure I haven't made any mistakes like I did in question 1. Actually, we didn't have any message saying text file created, but there it is. And it is the same. So it is fine. Okay, good luck with your exam and study hard.